Okay, so in this video, I'm going to kind of walk you guys through how to use the R coding cheat sheet because you'll be expected to do this each week for your homework. So to do that, we're going to go over the 4 examples that you'll find in the Lab 1 activity. So a couple reminders, you always want to make sure you're in the correct um, project. So it should be like your generic 342L assignment because we've already installed those packages, and that way you don't have to reinstall them. So if you're seeing a yellow banner, that should tell you that you're in the wrong project and you'll want to go get back into the one that we set up together. So the first, like the beginning of this document just has all of some basic instructions, but I'm going to verbally go over them. So we're going to skip through those. What you don't want to skip though is at line 65, we see the code for pulling in our packages, tidyverse and RStudioCloud. So you always want to make sure that you run the code to pull those packages into the document. All right, so no errors popped up. We're good to go. There are 4 worked examples that have to do with the old data that we used during last week. You can go ahead and ignore those for now. I'm just going to go over the actual activity since this kind of works through all parts, and the ones I skipped over just go over the stats. All right, so let's get into it. So the first question is telling us that we are kind of studying how humidity affects the earthworm activity. So the background info is basically saying you place earthworms in a chamber and you are controlling for humidity. Okay, so keyword you're controlling. So then what they did was they counted how many worms are above ground during each try. So what you're going to be asked to do, right, is visualize the data, meaning make a graph, and then prepare the analyses using the codes we have here. And then you'll make a figure caption, but that's at the very end outside of R. So let's go ahead and work through example 1. So it tells us here is the file we're looking for. It is called lab 1 worms. So I've already uploaded them into my R. If you have not, you're going to want to pause the video and go ahead and hit upload and then pull all those files into R. And remember, you always get your files from that week's module. So since I see I have all the files here, I'm going to go ahead and run this code chunk and select the correct file and hit OK. All right, perfect. So then what should happen is, again, remember you'll see there's a 1 and you're going to highlight everything after it, including the quotes. I'm going to copy it and then I'm going to paste it down below right in front of the comma. So when I paste it, it should turn green. Then I can run this code chunk. And now we have our kind of like preview of our data set. So we can see that we're looking at here's the relative humidity versus the number of worms. And then again, based off the info, we have established that there are 2 variables. We're looking to see if there's a relationship. And I don't know if I said this, we're controlling, sorry. We're controlling for 1 variable and we want to see if there is a relationship. So that should trigger in your head that we are going to run a regression. So what analysis are you going to run? Remember, everything in the white you can write in. So, and it won't mess up your code. So I'm just going to make it now. We're running a regression. Okay. Next, it tells us to go ahead and run that analysis. So here is where you go over to your R coding cheat sheet and you're going to go to the analysis section. And you'll scroll down, look for regression. Here it is. So now what I'll do is copy everything inside of that gray code chunk as so. Copy it. I'm going to paste it. Remember, you're going to paste it right in between, just like that. All right. Now, what we've just pasted in is generic code. So we need to go ahead and change everything that is in red. So first thing I see is name. Okay. So what you'll do is go up to the top to the key, and it says wherever you see data or name, that is basically referring to the name of the imported data set. To get the name of that data set, you're going to go to that initial code chunk and you'll see a piece that says red.csv and a little arrow. Everything before the arrow right here, that is the name of your data set. So this one is called worms. Basically, you just have to make sure it is same, like if it's if there's any capital letters, lowercase, right? It has to be exactly as it is. So what I'll do now is I'll come on back, and I like to keep it up right next to it so I don't have to keep going to different pages. I'm gonna go ahead and delete name and change it to worms, since that's the name of our data set. Then the next thing that's in red is the dependent variable. So you have to be able to look at your data set and differentiate which is the dependent variable. So for this one, we are controlling relative humidity. So that would be the independent variable. And then we are measuring the number of worms. So that would mean our dependent variable is going to be number of worms. So this is where I have to, again, make sure I do it exactly as it is written. So it's capital N, number, worms. Okay, perfect. Next thing that's in red is independent variable. So I'm going to go ahead and switch this out to be relative dot humidity. Oops. Perfect. Then the next piece that is red is again data, and we know that data is worms, which is just the name. And then down here, summary, leave that. We just need to again change the name to worms. Okay, so we have now changed everything from that was in red to appropriately reflect this file so we can run it. Beautiful. So then we get our output here. Now we don't need to do anything with this just yet, but I'm going to go over a couple of things. Because when you go to make your figure caption, after we've made our figure, you're going to hopefully know that because this is a regression, we need to have a regression line, right? And that linear trend line is going to have the formula y equals mx plus b. So we need to get that data from here. So to get that information, you're going to go where it says coefficients, and then you'll see intercept. If you just move over, you'll see a number. This number right here represents the b, right? So y equals mx plus b, it would be the negative 8.8 would replace the b. Okay, now the other thing you need in the formula is the slope, or the m. The m will always be right under it, that 0.24. So to write that out, just to make it really clear for you guys, y equals mx plus b. That's the generic formula. So we are going to do y equals m is the slope, which is right here, 0.24. B is right above it. It's negative, sorry, I'm going to put the x, forgot the x, negative 8.8. Okay. So remember, this is where you get that info. A couple other pieces of info you're going to need for a regression is the r squared. So right here, multiple r squared, this number is your r squared. Okay. Then you will need a p-value like always. Your p-value can be found right at the very end, right here. All right. Okay, so save that info for later, right? That's for when you make your figure caption. Now what we're going to do, since we've already run the regression, is we're going to make the graph. So to create the plot, you'll scroll down to the data visualization section of the cheat sheet. And since this is a regression, we're going to want to select scatter plot with regression line. So I'm going to go ahead and copy everything in the chunk, copy it, paste it. And then same thing, we're going to go ahead and change everything that is red. So data, you recall, is worms. Independent variable, again, is going to be, I'm going to make sure I get it exactly correct, relative dot humidity. The dependent variable, number of worms, number dot worms. Perfect. All right, next line is all black, nothing to change. Next line, all black, nothing to change. Next two lines, what these represent is the axes. Okay, so the y-axis is right here, and then the x. So because this is a regression, remember, these matter. So we need to make sure that on the y-axis, we have the dependent variable. So what I'm going to do is delete everything inside the quotes. Okay, so everything inside the quotes is what will show up on my graph. So I can type exactly what I want. You don't have to use any coding language. It's all good. Whatever I type in there will show up. So for my y-axis, it should be the number of worms, right? So I'm going to type number of worms. Then my x-axis is going to be the independent variable, which was relative humidity. And usually there will be units, right? But in this specific example, they didn't really specify the units. So you're not responsible for them for this particular example. But say there were units, you would write them in here. And on the next example, I'll show you exactly what that looks like. But in terms of this code chunk, we are done, right? We have changed everything in red. So let's go ahead and run it and see what we get. There we go. There is our graph. We have our trend line, our axes are labeled. And next, what you'll want to do is copy this figure into a Word document. And you can go ahead and do all the figures first and then copy them over. But just to show you, what I like to do on a Mac is I like to just, if you click down with two fingers, that's like a right click, right? And I just copy image, and then it's on my clipboard and paste it into a Word document. You could also save the image to your desktop. Worst comes to worst, you could always screenshot it, okay? Whatever is easiest for you, that will work. All right, so let's just keep going to the next example. Okay, so for example 2, we are looking at tadpole behavior in response to a predator. Okay, so the predator is the bullfrog. In this case, they put tadpoles in one side of a chamber and then recorded the amount of time they spent near that separator glass before and after the presence of that predator. So what we want to do is analyze this data and make a graph to see if the presence of the predator had an impact on the amount of time spent near the glass. So what you should be thinking is, okay, so keyword, before and after. Okay, if we're doing a before and after, in your brain, you should automatically be thinking a paired t-test. Okay, so let's go ahead and pull our data. So first thing we need to do is load in the data set. So we run the chunk, and we're going to select this one for tadpoles. And then we copy, again, everything with the quotes, copy, and we paste it right in front of the comma. It's green, that's great. So we run it and we see a preview of our data. So what we're most concerned with are these headings up here, because that, again, is what we're going to be using in our codes. All right, so looks good. What analysis are we running? We have decided we're going to do a paired t-test. Okay, so first thing we need to do is get the summary stats, right? That's going to mean get us the mean, the standard error, any info we might need. So we're going to go to the analysis. We're going to go to the data visualization section for a bar graph, right? Because if you are running a t-test, you have to use a bar graph, right? That is how you visualize a comparison of two groups. So it says first run the summary stats. I come over here to step 1, run the summary stats. So I'm going to copy, oops, just this, copy. You don't need to use this part down here, so I'm just going to leave that out. All right, so I'm going to paste it in. Beautiful. Then we just go ahead and change everything that is red. So remember, data is what did we title it, and it's already done for you. Tadpole. Is it tadpoles? No, just tadpole. Tadpole. And then we see data is red here as well. So group. If you're like, wait, what is group? Go up to the top. Group is the categories in your data set. Let's go back down. So the categories in our data set is going to be the exposure, okay? Because it's either before or after the exposure. So I'm going to change group to exposure. And then last but not least, we have one more red chunk here, which is dependent variable. And what we're measuring in this case is time, right? We're measuring the amount of time that they spent near the glass. Okay, so everything in red is good. I'm gonna run it. Perfect. Okay, so remember, when you run summary stats, it won't show up over here, okay? You'll have to come over here. What is this one called? Tadpoles, right here, okay? And if you click, sorry, this second one, I should make this bigger so you could see this one. Okay, then you get another tab, and again, it breaks it down after, before. Here's the n values. We don't need median or any of this. Here's the mean, standard deviation we're not using, standard errors there. All right, but we don't really need to do anything with that because R is going to go ahead and make the plot for us. But just in case you needed that info, it's there. So let's move on to step 2, which is create your plot. Step 2, create your plot. We're going to copy all of this and we're going to paste it. And we're going to, again, go ahead and change all the red. So our data is tadpole. The group is what is it? Exposure. Sorry, you forget, you just scroll up. Exposure. And then mean, it just stays mean, right? Because we're essentially just graphing the means as the bar, right? So it knows how to do that. Next line, nothing to worry about. Next line, nothing to worry about. It's all black. Again, we're going to go ahead and make our axes. So on the y-axis for this graph, we should have time, right? Because we are measuring how much time they spent. I don't know if it specifies here how they measured it, if it was minutes or seconds. We're just going to go with minutes. Obviously, when you're doing real data sets, you'll know exactly how you measured it, but these are just made up. So that's fine, that'll work. On the x-axis, it is going to be exposure, right? It's either before or after the predator was placed. All right, last line you can leave, so we'll go ahead and run it. And there you go. There is our graph. We have, it's kind of funny that it's after and before, but it's okay. We'll just leave it that way. Everything is labeled. We have our error bars. Again, you'll just copy and paste this and pop it into a Word document. All right, so now we can run the actual analysis, which is going to be our paired t-test, right? Before and after. So now I'll scroll on up to where we have our data analysis, and I'm going to go ahead and select all of the code for a paired t-test. So copy and paste. And again, we need to change out everything in red. So dependent variable is time. And then the group is going to be exposure. Data is going to be tadpole. And then we'll leave that as perfect. So now, right here, we see group 1 is denoted as after, group 2 is before. We have our n values. Notice they're the same. So when you go to make your figure, remember, paired t-test, it's just going to be one n value, which is n equals 12. And then lastly, you need your p-value, and that can be found right here. All right, so now we have all the data we need to pop this into a Word document and do the figure caption. All right, let's move on to number 3. Okay, so for number 3, we are going to look at hibernation. Okay, so here we're looking at the physiology of hibernation. So it says that they're recording body temperature and heart rates of 17 different bears. So this tells us our n is 17, and we have 2 dependent variables. Okay, it doesn't say we're controlling anything, right? It's just saying we're just taking data. Okay, we're just pulling heart rates and temperatures. And we're only trying to see if there is an association, which makes sense because we didn't control for anything. So what you should be thinking in your head, correlation. So let's take a look at the data. We're going to run this chunk, select hibernation, and then copy and paste again. Right before the comma. Green, great, run. Perfect. We have all of the headings that we're going to need to include. The analysis we're going to run, we have decided is a correlation. So now we're going to create our plot. So you'll go down to data visualization and you should be thinking scatter plot. Okay. Because this is a correlation, we do not want a trend line, so you cannot select the one below it. So scatter plot, and we do it again. So what is the data called here? I believe it is bear, right? So bear is data. Independent variable and dependent variable. Okay, now here doesn't matter, okay? There is no independent variable, so you can essentially kind of do it however you like when you're graphing, just so long as you make sure that this X is matching this label, okay? So I'm just gonna choose one, right? Doesn't matter. For my independent, aka the x-axis, I'm gonna do body temp, right? And I'm doing it just like this. For dependent, I'm gonna do heart rate. And again, make sure you're writing it exactly as is. Next line, we don't have to do anything. Now we have to write out our labels. So in the quotes, for my Y, heart rate, and then in the units, we write so beats per minute. Okay, great. So there's our Y. Now if we do the X, that is body temperature. Just the body temp. And it doesn't specify, but I'm going to assume Celsius based on the numbers I see. But again, you should not assume for when we're actually running data. You'll have that information. Cool. There we go. So now we have our graph, we have heart rate and body temperature for our correlation. Okay, now we're going to run the actual correlation. So you scroll back up, okay, to our data analysis, and we are going to go ahead and select all of this. All right, cool. So for correlation, again, it doesn't matter. They're just 2 dependent variables. So here you can make this body temperature or this body temperature, this heart rate or this heart rate, doesn't matter. So I'm going to just go ahead and do heart rate, and then body temp, and then remember the data was titled bear. Just make sure I had, yep, heart rate, body temp, and run it. Wonderful. All right, so variable 1 and variable 2 are here. The actual R, little r, correlation is here. We then only need the p-value, which is here. And then lastly, we do need the sample size or the n. So for correlation, you could input this code to get the sample size, or it did say it in the, like up here in the little blurb, it did say 17 bears. Or you could also go to bear right here and open the data set, and you can see that there are 17. Okay, 17 samples. I'm gonna get rid of that because we don't need it. All right, so then you have everything you need to make your figure caption. All right, last one. So now we are looking at bacterial physiology, okay, and how it differs across two habitats, a sandy and a clay habitat. So here it tells us again, the sample size is 15, okay, so there's 15 different bacteria in each habitat, and what they have done is recorded their respiration, okay. So you should be thinking, okay, we have two separate groups, and we want to perform an analysis that compares the respiration rates of the bacteria in these two habitats. So this is not paired, okay? Two completely separate areas. So you should be thinking unpaired t-test, okay? So let's go ahead and pull the data and take a look. So we run it, bacteria, scroll up. Let's go ahead and copy it in right before the comma. Green, great, run it. All right. Cool. So back, okay, short for bacteria, that is the name of our data set. We have the environment, which is either sandy or clay, and then here is the respiration rate that they're measuring. Okay, so what analysis are we running? So this is going to be an unpaired t-test. All right, so let's make our plot and then we'll talk about the analysis. Remember, any type of t-test, it's going to be a bar graph or a bar plot. So we scroll down to data visualization and we do our summary stats, which is always step 1. So we copy it and paste it, and then we're going to go ahead and change out everything that's in red. So this one is called back. So I'm going to change this as well. Okay, group. What is the group? Should be environment. And what you can do also to just like make sure you don't make a typo or anything, you can just copy and paste it. It's probably a better idea. Okay, then we need to know the dependent variable, and that is our respiration rate, right? That is what we're measuring in both environments. So we're going to copy, paste, and let's run it. There we go. Okay, so you'll see it up here now, okay? If I click on this, then it lays it out for me. Here's the two environments, the ends, and the means, and the standard errors, okay? If you just want to see what they were. But remember, you don't have to do anything with it because now when we create the plot, R will automatically pull it from our summary stats. So step 2, create the bar plot. We copy and paste. And boom. And let's go ahead and start changing everything out. That's in red. So data becomes back. Okay. Group, remember, was environment. we change that out because that's how we're grouping it. Don't be tempted to switch this to respiration rate. If you look over here, it's in black and it just says me, right? And that's by design of the code. Okay, next line, don't need to worry about it. It's all black. Next line, don't need to worry about it. All we have to do now is change the axes titles. Okay, so y, which is the dependent variable, is the respiration rate. And they didn't specify the units in this example, so don't worry about it. We'll just leave it as that. And then the x-axis name, it's either going to be the clay or the soil. So basically the environment, right? So environment. Okay. Run it. And there we are. So here you have our respiration rate. And then here's why we wrote environment to specify if it was clay or sandy. We've got our standard error bars and then our bars that represent the means. Okie dokie. So now that looks beautiful. Now let's go ahead and actually run the analysis. Now, when we did a t-test earlier, that was a paired t-test. Okay, there was no variance, right? It was the same group being tested twice. But now we're doing unpaired because we have two separate, completely separate individual groups. And we need to make sure that there is no variability because that will change the type of test we run. So we need to first run an F-test, okay? No F-test for paired, right? Because there's no variability. But when we do an unpaired, step one is always check the variance. So I'm going to copy the code for variance and paste it in. And let's go ahead and just start changing everything out. Dependent variable. First up, we're going to delete this. And our dependent variable, I'm going to copy and paste it just to be super sure I didn't make any typos. I'm having a hard time doing this. Okay. Paste it. Okay. And then group, again, was environment. No, I can't. So we change this to environment. And then lastly, the data set was back. Wonderful. Okay, so let's run it. Okay. So now our F-test is done, and what we're looking for is the p-value, because the p-value of the F-test tells you which t-test to run. So here we are, we see the p-value is 0.09, okay, and the threshold is 0.05. So you come over here, run t-test. So it tells you if the p-value is less than 0.05, you are running heteroscedastic. Here's the code. But if your p-value is greater than 0.05, you're running homoscedastic. And that's what we have here. So I'm going to go ahead and select the second one. And I'm going to paste it here. And again, same thing. We're going to change out our dependent variable. Okay, so respiration rate. Group. What was our group? Oh, group is environment. I could type these out, but copy and paste is always just better to avoid any typos. Our data is back. Variance equals true. I leave that because it's black, right? So we don't touch it. And there we are. So here's the info from our t-test, specifically our homoscedastic t-test. Okay, so when you go to make your figure caption, you're going to specify the type of t-test that you ran. Just write it here. It was a homoscedastic t-test. you do not want to say unpaired t-test. That's incorrect. You have to specify which of the two unpaired t-tests. Okay. So here we have it. We have the clay group, the sandy group. Both of them did have the same number. They both have an N of 15. We don't need degrees of freedom. We're just looking for the p-value, which is here. Okay. So remember, when you're doing an unpaired t-test, you're going to have two p-values. The first p-value was from the f-test, okay, for variance. Okay. That doesn't tell us if there was significance, okay, but it is still included in your figure caption, and you need to use the formatting guidelines to make that caption, okay? Then the second thing we did was we ran a homoscedastic, specifically t-test, right? Because of this p-value. And that gave us, this homoscedastic t-test gave us a p-value of 0.4, which is obviously greater than 0.05, and thus, hopefully you're thinking, insignificant, okay? So that's the p, and then of course your n. All right. And so that is all. Then what you would do, again, copy and paste your figure into Word, and then type up your figure caption. All right. So that is all for this video. One last thing I want to point out though, once you're all done with R, you should always check out the formatting guidelines before turning in any homework assignment. Okay, this is how we grade your work. So you're right here, make this a little bigger. Okay, here's how you format every single situation. Here's my bar graph. If you're wondering what do I include in it, it's right here. Okay, like I just said, this is kind of the tricky one where you have an f-test and a p-value. Okay, then where it says type of t-test that you ran, for our example, it was homoscedastic t-test. Then after that, you would state the p-value of that homoscedastic t-test, and then you would put in your two sample sizes. Remember, N1, N2, that's just a placeholder. It has to be specific to what is written under the bar graph. So for the example we just did, it would be N sandy and clay. Okay. Yeah, so you want to make sure you go through each of these and just make sure that you have everything that is included. And I do want to point out one last thing here. In this example, they have put the formula on the graph. Don't worry about it. You don't have to do that, okay? Like as I stated here, you just have to make sure it's written in the figure caption and you're good to go. All righty. That is all. If you have any questions, let me know, but hopefully this was helpful. If you want to do it again, it's really a great idea, okay, just to run through, get some repetition. You could always upload a new file and start over. But otherwise, just save this, leave it, okay? Remember, if you don't touch it, it saves it. So that way, during the semester, if you're having trouble, you can go back and click on it and see what we did. All right, thank you.